Up next in algebra is chapter 11. We're going to talk about simplifying radical expressions, and that's what you should be able to do by the end of today. So what is a radical expression? Well, it's something with a radical symbol. And a radical symbol, the one that you're most comfortable with, is the square root. They make roots that have a 3 here, and it's a cube root, or a 4, and it's a 4th root, or sometimes they just put an n there, and they call it an nth root. In Algebra 2, you'll talk about that stuff, but for this class, it's just square root. Now, this actual symbol here isn't called a square root, even though we refer to it as that. It's called a radical. And then anything that's put inside of this is called the radicand. That's what most of this stuff says, but this is super important. We are going to simplify radical expressions by removing perfect square factors from the radicand. So think back to your perfect squares. You should know these by heart. If I give you something like the square root of 4, hopefully nobody's reaching for their calculator. We know that it's 2. And the reason that is because we can literally make a square out of this. If I make a square with a side length of 2, my area is 4. That's where this comes from. The square root of 4 gives me a side length of 2. Now if I gave you something a little bigger like 81 and told you to take the square root, that's saying I have a square, its area is 81, how long is each side? And each side is 9. Those two numbers are perfect squares. So when I throw something like the square root of 20 at you, this is not a perfect square. There is no exact square that gives me 20. I can get close with something like 4 and 5, that'll give me 20. Or I can even type this in my calculator and I end up with 4.47-ish. And if I try to make a square that's 4.47 on both sides, I don't get exactly 20 in here. I get like 19.8 something, something, something. It's close to 20, but not exact. So what we're going to do is we're going to write the exact answer for this, the exact side length that we would need to make a square. And it's going to look a little funny because the answer to this is going to be 2 root 5. So it's still going to have a radical in it, but it's exact, where a decimal is not. So here are the rules that you need to know. There's one for multiplication and there's one for division, and they're exactly the same except for those symbols. The multiplication property says that you can split things that are multiplying up into 2 radicals, or you can bring them back together. This works both ways. And the same thing for division. If you have a big radical sign, you can split it up into 2 little ones, or the other way around. So let's use that. So when you are asked to simplify a radical expression, what you want to do is figure out how many squares you can make with these numbers. And remember, the square has the same length and the same width. So what we're going to do is we're going to break down these numbers into its simplest factors and then turn them into squares. So 50, break that down. 5 times 10 multiplies to make 50. 5 can't be broken down anymore, but 10 can, into 5 and 2. So these numbers here are its factors. And in order to make a square, you need the same length and the same width. So looking at these numbers, I can make a square with 5 and 5. If I tried making a rectangle with like 5 and 2, it's obviously not a square, so we don't care about it. So I can make one square of 5. Because of that, 5 goes on the outside, and there's a 2 left over. He doesn't have any other 2's, he can't make a square, so he has to stay inside of the square root. The square root of 50 and 5 times the square root of 2 are exactly the same number except one's simplified. It'd be like 3/6 and 1/2, exactly the same number except one's simplified. So let's try B. Forget about this -5 here for a second. All that's doing is being multiplied by what's on the inside of the square root. So break down 300. The easiest thing that I see is that it's 3 times 100. And then I know 100 is 10 times 10. And I know 10 is 2 times 5. I got 2 of those. So all of these numbers here that I ended up with are the factors of 300. And then make your squares. So I can make a square with these 2's, and I can make a square with these 5's. So I can make a square of 2's and a square of 5's. And then this 3 doesn't have anybody to square up with, so he has to stay inside the square root. So the square root of 300 simplifies to 10 times the square root of 3. And then we have to remember that negative 5 on the outside there. So we want to multiply this by negative 5. So this whole thing ends up simplifying to negative 50 times the square root of 3. That one's yours to do. So let's try some with variables. Variables act exactly the same way as they have before. Look at them separately, see what squares you can make, and then pull them out if you can. So let's look at 27. Break this number down. 27, 3, and 9. And then 9 can break down into 3 and 3. So I'm left with all the factors. And then remember, n squared just means n times n. So in order to make your squares, you need 2 of the same thing. So these 2 3's can come out, and these 2 n's, I can make a square of n that can come out. And then this doesn't have any friends, can't group up with anybody, so he has to stay inside the radical. Remember, we are making squares, and you are talking about the square that you are making. So this 3 times 3 is 1 square. This is n times n, that's 1 squared. And this is like 3 times 1. Not a square, so it stays inside the square root. I'm going to leave you this one. Let's do C together. So this one, what we really have here, if we break this down, remember x squared is x times x. Y to the 5th means that I have 5 y's. And remember, you need to make a square before you can leave the square root. So here's 1 square of x that can come out, 1 square of y that can come out, another square of y that can come out. This y doesn't have any friends, so he's got to stay inside. And then we'd want to simplify this. This is really x times y squared times the square root of y. So that was multiplication, where we didn't have to break anything up. But now let's look at these and use that rule that we figured out. So in order to simplify each radical expression here, always check to see if these are perfect squares on their own. If they are, it'll make your life a lot easier. If not, let's combine them and see what we get. So the rule says that I can turn this into one big giant square root with both of those inside, and then we can simplify that. 13 times 52 gives me 676. Since this isn't a perfect square that you might know off the top of your head, double check. Take the square root of that and see what you get. And if you take the square root of 676, it is a perfect square. You get 26, and you're done. So let's try C. I'll leave you B to do. So this one's weird because we got numbers on the outside and numbers on the inside. If you're on the inside, you can't hang out with people on the outside, and if you're on the outside, you can't hang out with people on the inside. So treat them separately. Multiply just your outsides together. So 2 times 6 is 12, and then multiply just your insides together. 5 times 10 is 50. A squared times a cubed is a to the 5th. And then we get to simplify. So break this down. We've done 50 before. We know it's 5 and 10, and then 5 and 2. So we can take out a group of 5's. So on the outside we have that 12. We could take out a square of 5. And then let's look at the a's. If you have 5 a's, you can make 2 groups. So a squared. There's 1 guy left inside. And remember, there's also this 2 left inside. So once we simplify this, 12 times 5 is 60. A squared times the square root of 2a. And that's the simplest form of C. So now that we've done all this multiplication, let's do some division. So if ever you have a giant square root like this, simplify what's inside the square root first, and then see if you can go from there. So this first one, 144 divided by 9, simplifies to 16. So then this problem is the square root of 16, which is 4. And we're done. But one like this, the next one, I can't simplify this. P and Q are two different letters, and there's no numbers that can be reduced here. So I'm going to use my rule. And the rule says that I can split this up into 25p cubed divided by q squared. So now we basically have two problems in one. We got to simplify what's on top and simplify what's on bottom. So I know that the square root of 25 is something nice and pretty. And I can split that up with the p cubed. Square root of 25 is just 5. And then remember, p cubed is p times p times p. So I can make one group of p's, and then there's one p left inside the square root. Where on the bottom here, q squared just means that I have q times q. So I can take one group out, and there's nobody left inside. So as messy as this looks, this is simplified from that. C is yours. So let's work on these. 90 divided by 5. If you simplify that, you end up with the square root of 18. Now this isn't a perfect square, but we still have to check and see if we can simplify it. So what we're going to do is break down 18, just like all of our other numbers. So 9 and 2, 3 and 3. I can make a square with these 3's, but this 2 doesn't have any friends, so he has to stay inside. So 3 root 2 is exactly the same thing as the square root of 90 over 5. Now when you get one that looks like B, 48/75ths, you can't simplify this. If you try typing that in your calculator, it gives you a decimal. You could find the greatest common factor in there, and there's a 3 in both of them, and factor that out. Or you could square root both of them. If you do this, then you get to simplify both of these. In the square root of 48, we got to break down, so any numbers that make 48, let's say 8 and 6. Break down 8 is 4 and 2. Break down 4, 2 and 2. 6 breaks down into 2 and 3. And then find some squares. So I can make a square of 2, square of 2, and then this 3 doesn't have any friends, so he stays inside. So I pulled out 2 2's and 1 3 inside. And then do the same thing for 75. So 75 breaks into 3 and 25. 25 is 5 and 5. So I can make a square with that, so that comes out. And there's a 3 stuck in there. Now when I simplify this, 2 times 2 is 4. I have 5 root 3. Since both of these have a root 3 on top and bottom, guess what I can do? Cross them off. So this simplifies to 4/5. Try C on your own. Simplify what's inside of here first before you try taking the square root. Last thing that we got to talk about. A radicand in the denominator may not be a perfect square. To simplify, you need to rationalize the denominator. This is very important. You need to know what this means, rationalize the denominator. This means square roots are not allowed in the denominator. In order to fix that, you need to multiply by a big giant number 1, and that's what rationalizing the denominator does. So this first one's going to look kind of weird. Stay with me. So this square root, not allowed in the denominator. I want to get rid of it. So what I'm going to do is I'm going to multiply it by itself. And I can't just go multiplying the denominator by something, so I have to multiply the numerator as well. And when you look at this, remember that this is just a big, giant number 1. And it doesn't matter what I multiply by as long as it's not anything besides 1. So when I do this, I end up on the top with 3 times the square root of 3. And on the bottom, remember I can multiply those numbers together, so I get the square root of 9. And something magical happens. The square root of 9 is a perfect square, and this should happen every time. So you end up with 3 root 3 divided by 3. There's no more square root in the denominator, which is what we want. We want to rationalize it. And then we can simplify this. 3 divided by 3 is just 1, so this ends up as the square root of 3. So if we try one like C together, so you see if you can simplify what's on the inside here, and we can't, so then split it up. Square root of 7m divided by the square root of 10. And then these can't simplify, but we cannot leave a square root in the denominator. So what we have to do is multiply top and bottom by the square root. Because remember, all we're doing is really multiplying by 1. And you don't change the number if you multiply it by 1. You just change the way that it looks. So when we do this on the top, you multiply the insides together, you get the square root of 70m divided by the square root of 100. And the square root of 100 is a perfect square. That's just 10. We no longer have a square root in the denominator, and we're done. 70 can't be broken down. It breaks up into 7 and 10, and then you still can't make any squares. So we are done. This is a helpful tool to figure out when you need to keep going. Something is in simplest radical form when the radicand, remember the number underneath, has no perfect square factors other than 1, so you can't make any more squares. You're not allowed to have fractions, and you're not allowed to have a denominator with a radical. So I left you plenty of problems to go back and practice on. We'll go over them in class tomorrow, so make sure if you are confused that you write down where, and we can talk about it. Enjoy your night.